Good day everyone, my name is Kate Bilid of ECE 3A, and today I'm going to present to you my performance task number 9 in ECE 23. And I'm going to demonstrate how arithmetic encoding and decoding works, and how to decode the binary code. And for this activity, we are going to use my ID number as reference. Now given the information or message, how do we decode this message? 2019-2315A. Recall that one important characteristic of arithmetic encoding is that we need to put a symbol which will signify the end of message. So for this task, letter A in our ID number will represent the EOF or the end of file. Now, probabilities will depend on the number of occurrence of each digit or character. In our ID number, symbol A is 1 of 10. So 1 over 10 is equal to 0.1. And this 0.1 is gonna be our probability value. Next is 0. So 0 is 1 of 10. So that's equal to 0.1. 3 is 1 of 10. That is equal to 0.1. 5 is 1 of 10. That is equal to 0.1. And 9 is also the same. And the dash also a 0.1. Now 1 is 2 of 10. So 2 over 10 is equal to 0.2. And 2 is 2 over 10, which is also equal to 0.2. And summing up the probability values, we get a total of 1.0. Okay, let's start. So you see, letter A takes 0.1 delta step. The same with 0, 3, 5, 9, and the dash symbol. And for letter 1, it takes 0.2 delta steps, and the same with 2. What we're going to do is take the difference of the upper and lower boundary value of every symbols in the message and divide it to the number of symbols present in the message, which is 10. And that will be our delta step values. And after that, we expand every symbol along with the range and will further subdivide this into 10. And repeat the process until the termination character is encoded. Let's start. Now from our message, what symbol did we transmit first? So it's number 2. The upper value is 0.2 minus the lower value divided by 10. We'll have 0.02 as our delta step every level. Now let's expand this range. Now 0.2 have become our upper boundary, while 0.0 have become our lower boundary. Next, after 2, we have 0. So rescaling that, we'll have 0.18 as our upper value, and 0.16 as our lower value. Taking the difference of the two and divided by 10, we'll have 2 times 10 raised to negative 3 as our delta step every level. Expanding this range, with correct calculations, we'll have these values every level. So we now finished expanding 0. Next we'll have 1. We're scaling 1 will give us 0.168 as our upper boundary value and 0.164 as our lower boundary value. Taking the difference of the two and divided by 10, we'll have 4 times 10 raised to negative 4 as our delta step every level. Expanding this range with correct calculations will give us these values every level. Next is 9. Excuse me. Rescaling 9 will give us 0.1664 as our upper value and 0.166 as our lower value. Taking the difference of the two and divided by 10, we'll have 4 times 10 raised to negative 5 as our delta step every level. Expanding this range and with correct calculations, we'll have these values every level. Next is the dash symbol. So rescaling the dash symbol, we'll have 0.1662 as our upper boundary level and 0.16616 as our lower boundary level. So taking the difference of these two values and dividing it by 10, we'll have 4 times 10 raised to negative 5 as our delta step every level. Next is 2. Excuse me. Expanding number 2 will give us 0.166168 is our upper boundary level, and 0.16616 is our lower boundary level. So taking the difference of these two values and dividing it by 10 will give us 8 times 10 raised to negative 7 is our delta value. Next is 3. Next is 3. So rescaling number 3 will give us a value of 0.1661664 as our upper value, and 0.1661656 is our lower value. Taking the difference of the two and divide it by 10, we'll have 8 times 10 raised to negative 8 as our delta step every level. So expanding this range with the correct calculations will give us these values every level. So rescaling 1 will give us an upper value of 0.166166592 and a lower value of 0.166165676. And taking the difference of the two and dividing it by 10, we'll have a delta step of 1.6 times 10 raised to negative 8. Next is 5. So rescaling 5 will give us an upper value of 0.166165872 and a lower value of 0.166165856. So taking the difference between the two and dividing it by 10 will give us 1.6 times 10 raised to negative 9. So expanding this range and having the correct calculations will give us this value every level. And the last symbol signifying the end of the transmission, we now encoded the terminating symbol, which is letter A, which signifies the EOT, or the end of file. So it is located in between the boundary of 0.166165872 and 0.166165870. So this was the upper bound and the lower bound. To get the middle bound value, we simply got the median between the upper and the lower value. So next step is convert the middle bound to binary. So I did this. It is a 34-bit binary. And for the coded message, it is just simply the binary fraction. To check, just simply convert the binary value of the middle boundary, this, back into its decimal value. So we have this. This is exactly the same as our middle bound value, so my calculations was correct. Now we have the average bits per symbol. It is given by the number of bits over the number of symbols. So 34 divided by 10, we have 3.4 bits per symbol. Now we have finished encoding. Let's start decoding. Decoding is just simply finding the location of your decimal value in the plot. So where does this decimal value lies in the plot? So it lies between 0.18 and 0.16, and the number associated with that is 0. And for 2, it lies in between 0.2 and 0.0. Next, where can you see this decimal value in the next plot? So it is located in between 0.168 and 0.164, and the number associated with that is 1. Next, where can you see this in this plot right here? So it is located in between 0.1664 and 0.166. And the number associated in between this range is 9. In the next plot, it is located in 0.1662 and 0.16616. And the character associated in between this range is the dash symbol. Next, in the next plot, it is located in between 0.166168 and 0.16616. So the number associated in between this range is number 2. Next, where can you see this decimal value in this plot? So it is located in between 0.1661664 and 0.1661656. And the number associated with this range is 3. And for the next plot, it is located in between 0.166165592 and 0.1661656. And the number associated with that is 1. Next, this decimal value in this plot can be seen in between 0.166165872 and 0.166165856, and the number associated in between this range is 5. And next is the A. And this decimal value can be seen in between the boundary of 0.166165872 and 0.166165874. Now in summary, we managed to find our upper bound, middle bound, and lower boundary values. We got the code word, we checked the accuracy of our middle bound conversion, and it was correct. And our average bits per symbol is 3.4 bits per symbol. So that will be all for today. Thank you.